All right, let's work with some percents here. So first thing, what we need to know about percents is that anytime we have a percent, let's just grab my 75% over here. If I want to write it as a number, I need to put it over 100. Right? We kind of did that in our percent proportion the other day, 75 over 100. Well, what would that be as a decimal if I took 75 divided by 100? Well, anytime you divide by 100, all that really happens is it moves the decimal place 2 spots to the left. Right? It almost like takes away zeros in a way or moves the decimal place. So if I think about the number 75, there's an imaginary decimal place at the end of it, right? Because it's like 0.0. We just never see it. So if I divide by 100, the decimal spot moves 1, 2 to the left, so that becomes 0.75. And you could check that on a calculator. So before we do any operations with percents, always change them to a decimal or a number. So change percents to decimals, or an actual number that we can work with. So for example, in this first guy, well, if you notice all these say 75% of 210 or 3.2% of 24. It has that word of. Whenever you see the word of, always think multiply. And just the other day we saw the word per. When you see the word per, you should think divide. So remember those things. Of, multiply, per means divide. All right, so let's go back to this 75% of 210. So it's nice and easy. We've already talked about this. If you want a percent of a number, all you do is change your percent to a decimal. So there's an imaginary percent here, and we always move it 2 to the left. So now it's 0.75, and of tells me to multiply. So I just take 0.75 times 210 on my calculator, and I get 157.5. And with percents, always make sure your answer is reasonable. Well, 75% of 210. I know it's less than 210. It should be more than half, kind of halfway through. So half of 210 is about 105. It should be right in between there. Yeah, 157.5. That seems reasonable, right? So always make sure that it makes sense, it's reasonable, things like that. Okay, the most common mistake on the second guy is I see this. A lot of people will do this. Well, it's already a decimal, 3.2. So they just go 3.2 times 24. Is that correct? No, that's a percent. 3.2 is the percentage. And then I see a lot of this. They'll write 0.32 times 24. Well, is that 3.2% as a decimal or as a number? No, because how many spots do you have to move your decimal place? 1, 2. So the decimal is now here. Well, what do I put in that empty spot? Yes, a 0. So that's incorrect as well. So we need to go 0.032 times 24. So remember, always move the decimal place 2 to the left when we change percents. And when we multiply those two, we get 0.76. And since it terminates at the 8, we can just leave it just like that. If it would have went on forever, we could have rounded to like the nearest 10th or 100th. And the last one, 42% of 3.5. Well, 42% is close to 50%, and 50% is like a half, right? So what's about half of 1.5? It's about 1.75. So we should be just a little bit less than 1.75 when I calculate this. So for 42% as a decimal would be 0.42, and times 3.5, yeah, that gives us 1.47. So that seems reasonable. That's good. All right, so just knowing how to find the percent of a number is very, very important when we work with our story problems here. All right, so first thing, Ashley attempted 40 baskets and made 85% of them. How many baskets did she make? All right, so just be careful. Sometimes you need to read through twice and need to really break this down. So think about, what's the part, what's the whole, things like that. So in this, she attempted baskets and she made baskets, right? She made and attempted. So think about made is kind of the part and attempted is like the whole, right? So if she made, we don't know how many, right? So we don't know how many. So I could set up a percent proportion. I could have went X over 40, right? Because we don't know how many she made and she attempted 40. And I could set that equal to 85 over 100. Sure, I could do that. But now that we're good with our just finding percents of a number, aren't we just looking for 85% of 40? See, of them, 85% of the 40. So there I could just take my 85% and change it to a decimal, which becomes 0.85, and take it times 40. That seems a lot quicker than going through that whole percent proportion. So that's what I'm going to go ahead and do. So that gives me 34. And make sure with all your story problems, we have a label. So she made 34 baskets. Always have labels. Okay, so the percent proportion's fine, but why not go the quick route now that we got this equation, finding percents of numbers? So now the tough part is when there's increases and decreases in percents. We're not just simply finding percents of numbers. So for example, this guy says you buy shoes that are on sale for 20% off. If the original price was $39.99, what is the sale price? Okay, and we're going to do this two ways. We're going to do it the little bit longer way, and then we're going to look at the short way. So a little longer way, let's think about this. Are we going up or down, first of all? Yeah, we're going down, right? We're going down 20%. So really, it's a decrease, right? It's a decrease of 20%. And that 20%, if I wanted to write it as a number, I would change it to a decimal, right? And I'd say 0.2. So 20% is really 0.2 if I'm going to use a calculation. And then the equation. So let's think about this. Well, could I find 20% of $39.99? Let's just do that first of all. So I'm going to find 20% of that. So it would be what? 0.2 times $39.99. And let's just go ahead and calculate that. We're going to look here. I get 7.998, so I get 7.998. We always want to round it to the nearest hundredth for money. So that means I'm going to round up. So it's about $8. So it's approximately $8. Is that my answer? Is my answer $8? Be careful. What is your question asking for? It says if the original price is $39.99, what is the sale price? It's asking for the actual sale. So am I paying $8 for these shoes? No, all we calculated was the percent that's being taken off. So what would I really have to do with this 8? Yeah, I'd have to subtract it from the original. So it's really $39.99 minus that $8. Or really in that equation, we're taking the original minus the discount. So minus 0.2, right? 20% of $39.99. And after we subtract $8 from it, then we get our answer of $31.99. Okay, so that's a little bit longer way. Here's the quick way. So I want us all to get good at doing the quick method. All right, so let's think about this. If it's a discount, our original price, I'm going to put this over here. I'm going to put my original price is 100% of the cost, right? So here's my original, $39.99. That's 100% of the cost. And now we're saying it decreases by 20%. So if it decreases by 20%, what percent are we paying for? Well, 100 minus 20 would be 80. So we're really paying 80% of the total cost. So I'm going to write that here, 80%. So does that make sense? If it decreases, if there's like a sale or a discount or something like that, we could think about how much we're actually paying instead of calculating the discount and having to subtract. Because now think about this. If we take our $39.99, our original, and find 80% of that, so that means this 80% is a decimal, which is 0.8, right? Move it 2 to the left. That should give me my new cost, my new sale price right away. And if I do that, that's what I get. I get $31.99. So it just calculates the new cost without having to find the discount and subtract it. So preferably, let's get used to doing this method because that's going to save you some time. Another way to think about this, let's go back to this last step before I did that times 0.8. If I use numbers, okay, well first I'm going to write up here. So I'm taking 100% and I'm subtracting 20%. If I use numbers for that, and I write my parentheses for my times, what's 100% as a number? We'll move it to the left. 1. We're decreasing, right? So minus, we're really taking 1 minus 0.2 to get that 0.8, right? Before we multiplied. So whenever there's a decrease, know that you can always take 1 minus that decrease in percent, right? Writing that percent as a decimal. In this case, we subtracted 0.2. So know that, because once we get to increases, it's going to be just the opposite, and we'll see that in a sec here. So same thing, except now we got an increase because we're buying candy for $12.50 and it has a sales tax of 7%. How much would you pay in total? Well, let's think about this. I could do what I did last time. I'm not going to do it this way, but I could take 12.5 times 7% as a decimal. Just be careful. What is that as a decimal? 1, 2. Remember, so it's 0.07. I could do that and calculate that, and then I'd have to add that value onto my original, right? I'd have to add it on because tax gets increased on, right? So this is an increase. It's going up. So I could do that, but we're not going to do that, okay? Because I think that just takes longer. If you like that, that's fine, but let's look at a quick method we could do to that. So our original cost was $12.50. So that's 100% of the cost, right? That is 100%. And we are adding 7% to that. So then my new total would be really what percent? Well, 100% plus the 7% tax that's going on it. So really we're finding 107% of my original, right? That 7% added on top. So let's make sense of that there. So it's kind of the opposite of just what we talked about. So I have my 12.5. So I'm going to bring it over here, 12.50 times, right, finding a percent of a number. Well, instead of doing that 0.07, remember just like the last slide, we had 1 minus 0.2. Well, now we can say 1 plus what? What is that 7% as a decimal again? 1, 2. So it was 0.07. Which is what? The decimal form of 107%. So really I can take 12.5 times 1.07 to find my new total, which is 13.375. Remember we rounded the nearest hundredth, so I'm going to go $13.38. We're rounding up there. Okay, just be careful with this guy here. It says a manager estimates Julie has worked about 60% more hours than usual. If she works 72 hours, what is her usual amount? Well, think about this. Is this her original? Is 72 her original? No. The usual is the original, and this is the new. So be careful with that. So let's think about what we've done in the past so far. So for our first example, it was a decrease, right? And we took the original amount, and we took it times 1 minus the percent as a decimal. So we had the percent as a decimal. And that gave us our new total, right? And then for an increase, when it went up, that was our last example, we took our original, and we took it times 1 plus the percent as a decimal. So in this case, that was 0.07. In our first example, that was 0.2. And that gave us our new amount. So let's think about here. Now we're given the new, but we do not know the original. So that's kind of confusing. And is it an increase or decrease? Yeah, it's an increase. It's more hours, right? So I know that this guy's an increase. So I'm going to put increase here. So that means I know I'm probably going to be using my 1 plus something, right? And we got 60%. So what's 60% as a decimal? Yeah, 12.6 or 0.60, whatever you'd like to use. Okay, so that's what I did here, 60%. And really that's 1 plus 0.6. So really we're doing like 160%. And we don't know the original, correct? We don't know it. That's what we're trying to find. And in this case, we usually just take it times that 1.6 or whatever that is. Well, since I don't know it, I'm going to give it a variable. I'm just going to call it x. So the original we don't know, we're going to call it x. So I'm going to say x times 1 plus 0.6 equals our new amount. Well, do I know the new amount? Sure. Okay, so let me simplify this left side. 1 plus 0.6 is 1.6, and we're still taking it times x, equals the new amount, which is 72. So how could I solve for x here? Yeah, we're multiplying, so what's the inverse of multiplying? With divide. Whatever I do to one side, I do to the other. So to solve for x, I would take 1.6 divided by, or 72 divided by 1.6. and I end up with 45. So she worked 45 hours normally. Okay, and you might ask, well, why don't you just go back 60%? Okay, and we're going to talk about that in class, why you can't go back 60%. The last thing we're going to look at is finding an actual percentage. Right? In this case, as I read through the problem, it says the manager changed the price for the pasta dinner from $7.25 to $6.95. What is the percent of decrease? Okay, so there's a couple ways we can think about this. One of the things we could do is we could apply the percent proportion. We could find out what percent $6.95 is of $7.25. Or I could think of it as the equation. And if you think about it, $7.25 was our original. And remember, we take our original times our percent, which I don't know in this case, so I'm going to call it P, to give us our new total. And I'm just going to set up that percent proportion over here. So is over of, or part over whole, which would be $6.95 over $7.25, equals the percent, which I don't know, over 100. So either way will help me solve for P in this case. But once I actually solve for P, which they'll be slightly different depending on which one I choose. If I go over to my equation, I'd be dividing by 7.25. So when I get an answer, P is written as a decimal and not as a percent. So I'd get 0.9586, which is which percentage? Well, remember, for a percent, we have to move our decimal place 2 to the right. We're just going the opposite. So it's really 95.86%. I could round that to 95.9%. Okay. If I did it on the red, if I did the percent proportion here, I would actually get the percent, right? Because when I put it over 100, it's actually a percent, so I would have gotten 95.9, and there's no moving of a decimal. So let's think about that. Is that my percent of decrease? No, that's what we're saying, that 695 is 95.9% of 725. So how do I find the percent of decrease then? Well, let's think about it. If 725 is the original, I'm going to put this in the middle here. So 725 is the original cost. That's 100% of the cost, right? And then we said that 695 is 95.9% of the original cost, right? So if I want the percent of decrease, I can just look at how much my percent decreased here. So I can take 100 minus 95.9, and that would give me about 4.1% decrease. There we go, 4.1% decrease. So that's one way to find it. I could just find the percent, that 695 is of 725, and then subtract that from 100. That's one way to do it. The other way to do it is anytime you're finding a percent of change or a percent of increase or decrease, right? If you can remember this, change over original, that'll help you. Change over original. If you can take how much it changes and divide it by the original amount, that'll also give you the percent. So let's do that here on the bottom. Well, how much did 725 to 695 change? Well, what would I do to find the change? Change, we would subtract them. 725 minus 695, and I would get 0.3. And then we got to divide, so that was the change, right? And then we divide that by the original. Well, what was the original? 725. And if I divide those two, I get about 0.041, which as a percent would be what? We'll move it 2 places to the right, about 4.1%. So there we go. I get the exact same answer. So that's another way to do it. If you can remember, anytime you're finding a percent of change, a percent of increase or decrease, you can just take the change and divide it by the original and change that into a percentage. Okay, so I'm throwing a lot of things about percents at you here today. So we got to get these cleared up as we work tomorrow. One more thing, mental percents. And you're going to fill the rest of this out on your own, but I'm going to help you get started. Okay, so the key here is the easiest percent to find. Well, obviously 50% is pretty easy, but 10% is the easiest one to find and the one to base it off of. So base everything off of 10%. That's going to help you the most. And why 10%? So let's think about that. Let's start with our first example of $40. If I wanted 10% of 40, I could take 10% as a decimal and say 0.1 times 40. Well, if I did that, I would get 4.0. 4.0. Well, what if I did the same thing to 500 here? What if I did 0.1 times 500? What would I get? I would get 50.0. So what's happening when I'm taking 10% of my number? All that's happening is wherever my decimal place originally was, so in the 40, it just moves one place to the left. Same thing in my 500. It moved one place to the left. So it's nice and easy. If I want 10% of something, I just move my decimal place one to the left. It's that easy. So taking 10% is really like, dividing by 10, taking 1/10 of something. So we just said 10% of 40 is $4. And 10% of 500 is $50. Well, is that going to help me? I could do the same thing for $2. If I wanted 10% of that, I move my decimal place one to the left. So it's really like 0.2. Well, how would I write that? 20 cents, right? Okay, would that help me solve the rest of these in the row? Let's go up to the $40 one. Okay, so if 10% is $4 and I want to go to 5%, what do you think I would do? Oh yeah, I could just divide by 2, right? Cut it in half. So that would be $2. So that should help me for my 50. Right? 50 would be $25. And 20 cents would be 10 cents. It's nice and easy. Well, if I go the other way now, let's say I want to go to 15%. Well, it's 10% plus 5%, right? So then I could just add the 2. So I could take 2 plus 4, which gives me $6. I could take 25 plus 50, which is $75. Oops. And then I could take 10 cents plus 20 cents, which is 30 cents. There we go. Well, what about 20%? Which one would I base that one off of? Yeah, I'd look back to my 10%, right? It's double the amount, so I could take it times 2. So $4 would become $8, right? $50 would become $100. All right, let's just finish off these two guys. Well, I'm going to do the 20 cents. 20 cents would become 40 cents. Okay, hopefully we start to see the pattern. Well, I could just increase the 5% to get to the 25%, right? So I know 5% are these values. So if I go from 20 to 25%, I'm just gaining 5%. So I could just add on their 5%. So I could add 2 here, I could add 25 here, and I could add 10 cents here. Not too bad, right? So $10, $125, and 50 cents. I'm going to go 0.50. And then for the 50%, we could double again from the 25%. So just kind of think through. And once you get your 10%, you're good. All right, so what about if I'm given like $30 here? What would be the easiest to get to? Well, let's try to get to our 10%. 5% is half that, so double it to get to $60. And then you can keep going. So 10% is great. Well, what happens if I know it's 10%? Could I find the actual value over here? Let's look at my $50. Yeah, if 10% is 50, just move your decimal place back out. So what would the whole thing be? Yeah, $500. And then you could base everything off that. Well, what if you know that 20% is $100? What would 10% be? Oh, it's half of that, right? 10% is half of 20%. So I could take half that and get $50. Okay, you see where we're going with this? So everything's kind of based off of 10%. Even when you get down here and you find out that you're given the 25%. Well, what would be really easy for 25%? Not getting back to 10% now, but couldn't I get to 100%? What would I do? Yeah, multiply by 4. So I should multiply 10 by 4 to get to 100%. Well, where's 100% of my value? That's at the very first column. That's that 10 right over here. So $10 times 4, which is $40. Then I could find my 10%, which is $4, right? Moving your decimal place one to the left. so on and so forth. Okay, so hopefully that gives you an idea of how you can fill out the rest of this table.